Our universe might be inside a black hole. This concept has cropped up over the last few years, but it was recently brought up again as a result of a study conducted by Dr. Charles Lynn Weaver and his student Vihan Patel. Despite huge opposition from the scientific community, the study went through the civil and it was published in the American Journal of Physics journal. The findings of the line drawer are quite significant thanks to the use of a logarithmic diagram. It pointed out areas that contradict known laws of physics and reach into the realm of quantum mechanics. Ideas like this have been circulating over the last decades. Scientists, for instance, noted that in the first billionth of a second after the Big Bang, the universe began to expand at a speed greater than the speed of light, which means that until then space did not exist, so there was no universal speed limit. So one can logically deduce that the expansion of space slows down over time. Einstein's theory of relativity, however, states that massive objects bend space-time. Hence, the space around the black hole is clearly curved. Truth be told, spotting a black hole would be physically impossible if not for the fact that the matter absorbed by it, accelerated to incredible speeds, generates light and heat. The more matter a black hole absorbs, the bigger it becomes, just like its event horizon. Our cosmos contains three-dimensional black holes with two-dimensional event horizons. So the useful theory being analyzed assumed that there may also exist four-dimensional black holes, and we might inhabit a three-dimensional event horizon of one of these giants. That's what was suggested years ago. Meanwhile, Lynn Weaver and Patel have shown direct data suggesting that our universe might be a colossal black hole. Scientists pointed out lines on their diagram. They separate areas marked by them as forbidden by gravity from the space occupied by objects we know. In the fatty line, there are black holes whose density decreases as their mass increases, although the left side of this line remains theoretical. Astronomers have observed black holes of various sizes, from remnants of collapsing stars to supermassive behemoths. This pattern is well established and understood. Ninhiver, on the other hand, notes that the lines perceived there resemble an event horizon, which in one way or another envelops the universe observable by us. It's worth mentioning that the researchers used only data obtained from the Hubble telescope, so it's not out of the question that future observations made with the James Webb telescope could allow for even more precise determinations. If this thesis proved to be true, it would mean that the current arrangement of the universe may not be a coincidence, rather of complex multi-dimensional processes that we are not even able to observe. We live in such interesting times that we may get the answer to this question in our lifetime. It is worth mentioning that one of the first proponents of this theory was the Polish physicist Nikodem Popławski, who worked at Indiana University. His concept assumed that our whole universe is inside a gigantic black hole, which in turn is located in another super big universe. He presented his theories back in the year 2013, without gaining much sympathy from the scientific community in the process. Accepting such a hypothesis, however, allows us to explain some of the contradictions that exist in the contemporary theory of the universe. In the model of the universe developed by an American physicist, black holes occupy one of the fundamental places. Popławski postulated that these are entrances to hypothetical Einstein-Rosen tunnels, i.e. tunnels which connect different locations in four-dimensional space-time. In this model, a black hole is a tunnel connected to its opposite, i.e. a white hole, which is located at the other end of the subspace tunnel. However, this does not give us the opportunity to travel through the universe, as according to Popławski, the entire universe is hidden inside a tunnel connecting a black and white hole. This model of the universe, it's supposed to help explain the toughest issues in modern cosmology, like dark matter or dark energy. Some researchers already attribute to supermassive black holes The scholar claims that in such a system, space-time should twist. But detecting this fact can be very difficult, especially if we are part of this measurement. However, adopting such a model of the universe implies that every hole in our universe could be a gateway to another world. It is not clear, however, how many such universes may exist, and Poplawski himself noted that there is always a question about some primary universe and that where it is located. With this hypothesis, it's easy to get caught in a loop, and the dilemma will always remind us of the famous which came first, the egg or the chicken. Nikodem Poplawski points out here that in our universe, all black holes, stars and celestial bodies have their specific spin. From a logical point of view, it should be the same in a super large universe where there is a black hole with our universe. Fact also somewhat provides evidence to support this thesis, because as the scientist himself noticed, in one part of our universe, spiral galaxies turn left, and in the other, to the right. This is allegedly evidence supporting the hypothesis of space-time twists within the singularity between a black and white hole. Of course, it shouldn't be forgotten here that after more than 10 years, scientists still don't know what's happening. Did not push this theory too far forward. A study published by Charles Lynn Weaver, however, shows that there are some very interesting aspects of our reality, and the next new discoveries, they can give us a better look at the mysteries hidden in our universe. The question of whether the entire observable universe is inside a black hole, it remains unanswered for now, but it undoubtedly requires further thought and research. Perhaps creating a full map of the observable universe would give us more room for maneuver. What? Scientists primarily operate on a small segment, performed via the Hubble telescope. The most important from our perspective should be that new perspectives for research are happily undertaken by the scientific community. And what are your reflections on this topic? If it turned out that we all live inside a black hole, would it somehow change your perception of the world? Or maybe it didn't have any, even the slightest impact on your life. I encourage you to share such considerations below in the comment section. I also invite you to subscribe to the channel, click on the bell, support our activities, and of course, I hope we will hear from each other soon.